Hello students, this is teacher Benard from Trinity College Nabingo, and today I've come to teach you chemistry, and today we are continuing with our topic chlorine and its compounds, and specifically we are looking at the other compounds of chlorine, hydrogen chloride, hydrochloric acid, and then the chlorides. I hope you are staying safe, sanitizing, putting on your masks, and avoid unnecessary movements. Hydrogen chloride. How can we prepare it in the laboratory? We can prepare hydrogen chloride gas in the laboratory using the setup below. Basically, the reagents we use is concentrated sulfuric acid, and we can put it in the tap funnel, and we can use a flat-bottomed flask where we can put our sodium chloride. Why are we using a flat-bottomed flask? Because the reaction takes place at room temperature. We don't need to heat. And then we need concentrated sulfuric acid for drying the gas. And of course, we collect it by downward delivery because it is denser than air. So as we're describing the preparation of this gas, remember to talk about the reagent and container. Concentrated sulfuric acid, where is it coming from? Sodium chloride, where is it coming from? Concentrated sulfuric acid, where is it contained? And then we must talk about how we are going to collect the gas. Where is it going to be contained? In the gas jar. So you should describe something that makes sense. I expect you, from the knowledge of the procedure we always give you for preparing the gas, since you know now the reagents and then the apparatus, you should be able to describe for us the laboratory preparation of hydrogen chloride gas in a way that is precise and concise. Talk about the reagent and the container, how we purify the gas, and how we dry the gas, and then the mode of collection of the gas. Equation for the reaction is that you are seeing there, but I want to emphasize something. The product is sodium hydrogen sulfate and non-sodium sulfate, so you should always be keen about that. Then, what are the physical and chemical properties of hydrogen chloride gas? Physical properties: it is a white fuming gas with a choking smell. Actually, it comes off from concentrated sulfuric acid as white fumes. When you put concentrated sulfuric acid there, you see white fumes coming off, and those fumes are for hydrogen chloride gas. It is an acidic gas, and therefore it turns a damp litmus paper to red. It is highly soluble in water, and this can be illustrated using the fountain experiment. You should be able to describe the fountain experiment for illustrating high solubility of hydrogen chloride gas in relation to the fountain experiment for showing the high solubility of ammonia gas. We had already taught that before we broke off when we were teaching ammonia gas in nitrogen and its compounds. What are the chemical properties? Being an acidic gas, it can liberate hydrogen gas with metals. Being an acidic gas and it contains hydrogen, so metals that are more reactive than hydrogen can displace hydrogen from hydrogen chloride gas, and then you get hydrogen gas. For example, iron and then magnesium. You should be able to tell the observations. Here, a green solid is formed of iron 2 chloride with magnesium. Magnesium chloride is a white solid. When we bubble it through an aqueous solution of silver nitrate, we see a white precipitate of silver chloride being formed, and then due to that reaction you are seeing there, and then actually we use that one as one of the chemical tests for hydrogen chloride gas. We also observe dense white fumes when we get a gas jar full of hydrogen chloride and we invert it over a gas jar full of ammonia gas because of formation of ammonium chloride. Now, you should be able to explain why Hydrogen chloride gas conducts electricity in aqueous solution, but not in methyl benzene or benzene. The explanation here lies in water being a polar solvent, but methyl benzene is nonpolar. So hydrogen chloride gas is able to ionize in water. Since water is a polar solvent, and then it cannot ionize in methyl benzene since methyl benzene is nonpolar. So the formation of ions in water by hydrogen chloride gas, those ions help hydrogen chloride gas in water to conduct electricity, but since it cannot ionize in methyl benzene, it means that it will not be able to conduct electricity. The same explanation holds for part B. Because water is a polar solvent, hydrogen chloride gas ionizes in water to form hydrogen ions and chloride ions. The hydrogen ions react with the sodium carbonate or the carbonate ions to form carbon dioxide gas, which are the bubbles of the colorless gas. But since in methyl benzene, only benzene, hydrogen chloride gas cannot ionize because methyl benzene or benzene, they are nonpolar solvents. That means that there are no ions formed, and there are no hydrogen ions to react with the carbonate ions to liberate carbon dioxide. What is the chemical test for hydrogen chloride gas? When we bubble through silver nitrate solution, we say white precipitate of silver chloride. And then it forms dense white fumes of ammonium chloride with ammonia gas. Hydrochloric acid. How can we prepare hydrochloric acid in the lab? We have always been hearing hydrochloric acid, that colorless liquid, and we have been always using it in titrations. But how can we prepare it in the laboratory? We can prepare it by dissolving hydrogen chloride gas since it is highly soluble in water. What we need to note about this diagram is that we use an inverted funnel just touching the surface of water, since if we use a delivery tube inserted inside the water, there will be what we call a suck-back effect. The suck-back effect, after dissolving all hydrogen chloride gas in water, the pressure inside the apparatus or inside the flat-bottomed flask reduces, and that one causes the hydrochloric acid solution formed to suck back. The atmospheric pressure pushes the solution formed of hydrochloric acid, and then it sucks back inside that delivery tube to the flat-bottomed flask. But if you use an inverted funnel, it is not possible. So that's why we use an inverted funnel instead of using a delivery tube. So we first prepare hydrogen chloride gas, and then we dissolve hydrogen chloride gas in water. But should be able to describe very well. Talk about the reagent and container. Concentrated sulfuric acid from a tap funnel is added onto sodium chloride in a flat-bottom flask. The reaction occurs at room temperature or without heating, producing white fumes of hydrogen chloride gas according to the equation. Then we write the equation, and then these white fumes are dissolved in water to form hydrochloric acid. The exercise, so you should be able now to describe how we prepare hydrogen chloride gas using the apparatus above, and to answer all those questions there, because I've talked about all of them. What are the properties of hydrochloric acid? Since it is an acid, it turns moist. It turns a mass paper to red, even if it is not moist, because hydrochloric acid is already having water. It reacts with metals, producing hydrogen gas, but these metals must be above hydrogen. For example, magnesium, we shall get magnesium chloride and then hydrogen gas. Zinc, we shall get zinc chloride and then hydrogen gas. Copper, silver, mercury, they will not be able to liberate hydrogen or to react with hydrochloric acid to liberate hydrogen gas. Why? Because copper, silver, and mercury, they are less reactive than hydrogen, and therefore they cannot displace it from hydrochloric acid. I think you understand that. Then property number 3, like all acids, hydrochloric acid reacts with carbonates and hydrogen carbonates to liberate carbon dioxide gas. The observation here is always effervescence of a colorless gas, and in the future we shall see that we use it to confirm presence of a carbonate. All carbonates, they react with acids to liberate carbon dioxide gas. Property number 4, since it is an acid, it will react with bases. It will react with bases to form a salt and water only. For example, with sodium hydroxide, we get a salt of sodium chloride and then water. With copper oxide, which is also a base, we shall get copper chloride and then water. Copper chloride solution is a green solution. However, concentrated hydrochloric acid, like we saw in the preparation of chlorine, it becomes oxidized to chlorine gas. So potassium permanganate oxidizes hydrogen chloride gas to chlorine gas according to that equation, which you have already seen in the preparation of chlorine gas. Uses of hydrochloric acid, we use it to remove rust. Since rust is a basic oxide of iron, so hydrochloric acid will react with rust to form a solution of iron 3 chloride, and then like according to how an acid would react with a base. So the rust becomes removed from the metal before we can electroplate it. We shall look at electroplating when we are looking at electrolysis. It is used in the manufacture of plastics such as polychloroethylene. How do we test for soluble chlorides? To the solution of the suspected chloride in water, we add dilute nitric acid followed by silver nitrate solution. If you add all those reagents and then you say white precipitate of silver chloride, it means that a chloride is confirmed present. It means that the chloride is there. However, this white precipitate of silver chloride, it dissolves when you add concentrated ammonia to it. It dissolves because of that equation you are seeing there, due to formation of a complex of diamine silver ions. We shall look at these complex ions and how they are formed when we are looking at ion chemistry. So you don't need to be scared about that ionic equation. What is the effect of heat on chlorides? Most chlorides, actually all chlorides, they don't decompose on heating, but what happens is that they are stable, but those ones that are a bit unstable, they don't again decompose, but they just sublime. So chlorides do not decompose when heated, but ammonium chloride, aluminium chloride, and iron 3 chloride sublime on heating. We have something to note there. Most chlorides are deliquescent and therefore become wet and form solutions when exposed to the atmosphere. Sometimes they ask you what is deliquescence. Can you give examples of deliquescent substances? Most chlorides are good examples to choose. Examples of deliquescent substances. For example, zinc chloride, copper 2 chloride, aluminium chloride, iron 3 chloride are all deliquescent. Deliquescence means they absorb water from the atmosphere to form a solution. So, what are the soluble chlorides? All chlorides are soluble except silver chloride, lead 2 chloride. Lead 2 chloride is soluble on warming, and then mercury 1 chloride. So, when we are writing them in the equations, we always put S or solid as their state. And then when we are preparing them, we use the precipitation method of preparing insoluble salts. This is the end of the topic, chlorine and its compounds. Thanks for following. Stay home, stay safe, wash your hands regularly. Sanitize always and keep social distance. God bless and protect you. I remain teacher Benard Ssegujja. If for any further inquiries, please visit these links you are seeing here to get more resources. Thank you very much for